Hello, welcome to the video lecture of Basic Course of Strength of Materials. Well, I am Mr. L. Karthik, Assistant Professor, Department of Mechanical Engineering, Hindustan College of Engineering and Technology. You can further contact me on karthik.mech@hisat.ac.in. Now, the course of Strength of Material is designed in such a way that it covers the basics of materials and the strength, how we can use the structure. So we're going to discuss about the strength of the materials in this entire video series. The content of this course are, we're going to discuss about simple stress and strain, and with the help of the simple stress and strain we're going to calculate the deformation of the body. And next we move on to shear force and bending moment diagrams in statically determinate beams and bars. And next we discuss about stresses in beams and torsion, and also the relation between thin cylinder and thick cylinder, and also the functions of the cylinders. These are the major content of this strength of material subject. We are going to discuss about this, and also the springs. Basically, this strength of material which will be relying on the basic mechanics called engineering mechanics. Now this particular course on this engineering mechanics is basically three fundamental areas. They are static, dynamic and mechanics of materials. So it comes under the engineering mechanics subjects. In the early classes, we might discuss or we might study about static and dynamic forces. In this, particularly in this semester, we are going to look upon mechanics of materials. So, you notice probably that statics and dynamics mainly concentrate on the study of external body on rigid bodies, external effect on the rigid bodies. So there will not be any consideration about the deformation of the body. We don't worry about the deformation of the body, or the deformation of the body is neglected in static and dynamic analysis in engineering mechanics subject. Whereas in mechanics of material, we deal with the study of bodies which are subjected to externally applied loads, and also we need to focus on the deformation of the body. So these are the major difference between the static and mechanics of materials. We look at the aspect of internal effect of the load, which are acting externally, and the deformation characteristics of the structural member. Once we apply external load over the structure, there will be the formation of internal effects. Due to that, the deformation takes place. That we are going to discuss in this basics of strength of materials. So in this strength of materials, we are interested in these two aspects: internal effects of external applied loads and deformation that are caused within the body because of the externally applied loads. So please remember internal effect of the externally applied load, and also the next one is deformation that are caused with the body because of the externally applied load. These are the two aspects we focus on this strength of material subject. And in fact, both of these aspects, deformation of the load and the deformation, plays a major role or important role while designing a structure. Literally, we may not design a structure without knowing these terms, deformation. So in this aspect, strength of materials are very, very useful for young engineers and the industry persons. So static and dynamics are the study of external effect on the rigid body. Meanwhile, the mechanics of material is the study of internal effect and the deformation that are caused by the applied load conditions. So these are the major branches of engineering mechanics. In fact, we look into the design concept. So what is meant by design? When we try to arrive a particular size of the member, we need to know how much it deforms. I mentioned that we literally may not select the structure or design. We need to understand the concept called deformation. We need to know how much it deforms and what is the effect of the external load on the material which acts internally, and these aspects are dealt in the particular subject which are called as strength of materials. If you have a structure, if you have a pen, you don't know about the deformation property of this pen. Since you arrest the one end and you may give the load, external load on the another end. If you give too much of it will be broken. So we need to know how long it will withstand the external load. So that is deformation, the limit of the deformation we need to know. So that will be discussed in this strength of material subject. In fact, you look into this, you will find different names for this mechanics of material or strength of material subject. Some may call it as mechanics of material, and some may define this subject as mechanics of deformable bodies. Static and dynamic, in the earlier classes we have discussed static and dynamics is not a deformable body. But in this context, we may call it as mechanics of materials, mechanics of deformable bodies, or mechanics of solids, or in general we may call it as strength of materials. So whatever the name may be, we call the subject as basically, but this contains the same information, or they will give you similar information. So mechanics of materials or strength of materials or mechanics of deformable bodies or mechanics of solids, all are same, which will provide you the same thing. And now we may call it this as strength of materials. So in this video course we will discuss thoroughly about a strength of material. So what it is? So all branches of engineering deals with a physical system, the components, parts of which are assigned and defined by means of physical size and fabricated from some materials or different materials. We may not know about the deformable property of the materials that we need to find and that we need to study. Appropriate sizing is necessary for this part of safety. It should withstand the imposed force on them and also at the optimal cost and also the best design. We need to select the material based on the application. Without knowing the application, without knowing the deformation property of the material, it may not work. So we need to keenly observe these every points. Then only the material should give a successful one. Otherwise, it will be in a failure one. So it is essential to study the behavior of the material from the strength and deformation point of view, as well as the characterization of different kinds of force, which causes different types of stresses in the material. So since we have different stresses, in later we are going to discuss about what are the stresses which we are going to use or we are going to apply in this subject, strength of materials. So finally, the subject which deals with analytical deformation of the strength, deformation characteristics, which means stiffness, and stability of different member is normally designated as the name called strength of materials. So each and every engineer should know about this subject, strength of material. It is not only useful for mechanical engineers. Those who are all use the structures, they must understand the concepts of strength of materials. So the strength of material have the following characteristics. We may simply call the strength of material as or define the characteristics of strength of material by means of 3S. What are the 3S? The first S is strength of the structure, and the stiffness of the structure, and stability of the structure, or else we may call it as a parameter strength and stiffness of the material and stability of the material. These are the 3S characteristics of strength of materials. So once we start designing, we need to focus on these three things. And let me going to discuss about some specific objectives of strength of materials. It is expected that one should be in a position to understand the concept of strength of material. So here are some points to observe about the strength of materials, and also we may call it as the objectives of strength of materials. The classification of different kinds of force that structural components are subjected to effects of different forces on components and their solution techniques, and different types of stresses and deformation that develop due to forces. So the first one is the classification of different kind of force, and the next one is the effects of the different kind of forces, and the third one is different types of stresses and deformation that can develop due to the forces. These are the three objectives, and what is the scope of this subject? The scope of this particular course, which includes identification of different types of forces that the structural component will be subjected to. So different types of forces it may experience. So we need to discuss about that. And next, the systematic evaluation of the effects of these forces on the structural components. First, the different types of force we need to analyze, and what are the effects of this force. So once we start applying the external load on the structure, there will be some reactions. The deformation takes place. The effect of the force which causes deformation. We need to study about that. So that this subject will clearly explains you. And here are some approaches to utilize this strength of material subject. Mainly, it focused on the material which is useful to engineering applications. Mainly it is so since in strength of materials is used in wide areas of engineering and science and technology. So we need to understand the property of the material. The next one is, and also we need to know about some laws like the Newtonian mechanism that will govern the governing equilibrium of the forces. So we need to understand the governing concepts or governing equation to equilibrium of forces. And the another important thing is to know the mechanical characteristics of the property, how it should reflect once we apply the external load, or once we start the structures and start the members to fabricate and to get a complete structure, then we apply a load over the structure, it will react to the external load. So we need to understand the property of the material. The properties of the material are varied from material to material. Mild steel has different property and plastics has different property. So based on the application, we are going to apply it, whether it may be a mild steel or it may be a plastic. So in general, the properties or the stress or strain may be defined in SI units. Some kind of SI units are meters, maybe kilograms or seconds. It may be defined like these things. And let me explain about the few of the forces which will be available or which we going to apply in the strength of materials are body forces. So what are the body forces? The body force which acts throughout the body, and associated with the unit of volume, of the body. And we may classify the body force as gravitational force or inertia force as well as magnetic force. Okay, and next we move on to the surface force. The force which is acted on the surface of the body or area of element of the body. Look into this picture. The force which is acted over the surface. So this is called as surface of the body. And next one is internal force. So what are internal force? So due to the external force which is acting externally or outside of the body, but the internal force which is acting inside and causes some changes in the body. This picture will clearly explain you about the internal forces of the body. And the next we move on to concept of stress. So, in general, the definition for stress is load per unit area. So, whenever we are going to apply the load or external force per unit area, so it may be defined as called as stress. So, once we start discuss about concepts of stress, we need to know about the direction of stresses and also shear stresses and normal stresses called tensile stress and compressive stress. Since in the early class itself we know about shear stress, tensile stress and as well as compressive stress. And these stresses which are multiplied by respective areas on which they can act and also give as the force, and at the section of vector sum of these forces is known as stress resultant, which keep that in a body is called equilibrium, or as the resultant keep a body in equilibrium. To find this concept of the stresses. And finally, we are at the end of this video lecture. So what we have discussed and what are the things which included in this lesson are a general idea about the scope of the subject and typical applications and the concept of different forces and concepts of a free body diagram and concept of stresses. These are things we are going to discuss in future. Let me conclude this session with an example of some of the applications which is used in strength of materials. So building. So we all know about a building. If an engineer looks a building, not only a building, they see like a structure. So what are the load, the material should withstand the load and the deformation property, everything should be studied by an engineer. And some other applications are we construct a bridge. The bridge should bridging the gap between the two ends of the rivers. So there it faces different kind of loads. It's loading at the supports and the cars or lorries, the vehicles which crosses over the bridge, the movement load and also the flow of water, it also creates some load. Still the bridge withstand all the loads. So we need to study about the structure. And another application is aircraft structure. So aircraft structure, the structure, it's a typical application. Here also, the body should undergo some external forces, external load. but the material should withstand. Then only the aircraft successfully flies in the sky. So thank you for watching this video course. In the next course, we will discuss about the another concepts of strength of materials. Thank you.